Algebra 1, Module 4, Lesson 21, Transformations of the Quadratic Parent Function. Now, I've said this over and over and over again. What is a quadratic going to look like? What's the shape?
Parabola.
It's a parabola, which means the end behaviors are what?
There's two of them.
Yep, there's two of them. They're always going to be behaving the same way, right? They're either both going to be going up, both going down, both to the right, or both to the left. How many x-intercepts can they be?
Two.
There can be two. At most two, right? They're not going to be more than two. There could be one. What is the case where there's only one x-intercept?
When the vertex is on the x-axis.
Yes, when the vertex is on the x-axis. What about if could there be no x-intercepts? Yeah, if it's a positive quadratic and the vertex is above the x-intercept or the x-axis, then it's not going to cross. Or if it's a negative quadratic function and the vertex is below the x-intercept, then there will not be a solution. So looking at the exit ticket, it says this is our parent function, just x squared, just your typical quadratic. It says describe in words the transformations of the graph of the parent function, f of x, that would result in the graph of g of x that is equal to x plus 4 squared minus 5, and graph the equation. Well, let's just talk about what's going on here. This minus 5 is going to tell us what? That it's going to be a vertical translation down 5, right? Because it's negative. We're going to go down 5. Now, the x inside the parentheses here, that's when we start talking about our horizontal displacement. Because we're talking about our x. There's something happening to our x. So it's going to be moving left or right. But you have to remember that there is a built-in negative in this function. There's always a built-in negative. So since this is a positive 4, we're going to have a horizontal translation that is what? Four to the left. Because it's really a negative 4. Right? H is a negative 4. If you write these out, K is a negative 5. There's no A. There's no B. Well, they're just 1. So we don't have to worry about those. Well, there's no B's in this one, but there's no A here. Okay? So now then, can you tell me what the Y-intercept is? Normally, we would just plug in a 0, right? For our x, and that would give us our Y-intercept. So let's do that. If we plug in a 0, we would have 4 squared minus 5. Well, that's 16 minus 5, and that's what, 11? Everybody see how I did that? Now, so that means we're going to be like way up here somewhere. It's not going to be on our chart or on our graph. Now, normally my vertex for just a x squared parent function is at, excuse me guys, is at 0, 0. That's the vertex. Now, if I move that vertex to the left 4 and down 5, I'm going to be at negative 4 -5, which is like right here. Oops. -4, -5. Okay. Everybody see that? If I just do what I've said right here, I can move my vertex to its new resting place there. Now, I don't know what the x's are, and they're not going to be fun to find. I'll just be honest with you. If we were to solve this, it's not going to be a fun one. And luckily, we don't have to necessarily, because it doesn't say to make sure we know all these points and everything. All we're worried about is moving these around. So as long as you can know that that is the vertex. Man, so hard to draw doing sitting down like this. Okay. As long as you know that is the vertex shifted to the left 4 and down 5, you're fine. As I said, this is going to go all the way up to like a what was it, 9 or 11, and then this is going to react the exact same way. Any questions on that? Everybody